In this session we will learn binning pattern. Binning pattern is similar to partitioning pattern. Even here data is grouped into different categories. Then what is the difference? The difference is that in binning pattern data is grouped together in the map phase instead of doing it in the partition phase. And the map output itself is the final output. As a result, there is no reduce phase at all. All such jobs where there is no reduce phase are called map-only jobs. Map-only jobs are more efficient than the jobs that has both map phase and reduce phase. That's because there is no reduce phase at all. And since there is no reduce phase, map output will not be partitioned, it will not be sorted, and it will not be shuffled. Since all these phases are not executed, map-only jobs are obviously more efficient than the traditional jobs. Since map output itself is the final output, it is stored in the HDFS to make sure that the final output is reliable. Let's take an example to demonstrate binning pattern. The problem given here is, given a set of Stack Overflow posts, bin the posts into 4 bins based on the keywords like Hadoop, Pig, Hive, and HBase in the tag field. Also create a separate bin for the posts mentioning Hadoop in the body field. It means that for each keyword a separate file has to be created. Let's see the post dataset first. Here is the post dataset. In the post dataset, each post is either a question or an answer posted on the Stack Overflow website. If the post type is 1, then it is a question. And if the post type is 2, then it is an answer. Here we have the tag field. So we need to search for keywords in this field. Here we have the body field. As per the problem statement, we have to search for Hadoop keyword in this field. Altogether we have to search keywords in both the fields to create 5 bins. Till the previous sessions, we saw that by default there will be only one output file from each map task. But in this example, we have to create 5 output files from each map task. That is, all the posts that contain Hadoop keyword will go into one file. And all the posts that contains Hive keyword will go into another file. Similarly, we have to create 5 different files for 5 different keywords. Suppose there are 3 map tasks and each map task creates 5 output files. Then altogether there will be 15 files. That is, more the number of map tasks and bins, more files will be created. This is not good for name node scalability. More memory will be consumed in the name node. If we are comparing binning pattern with partitioning pattern, binning pattern is more efficient than partitioning pattern. That's because it is a map-only job. But in binning pattern, more files will be created, and this is not good for name node scalability. So you need to do a bit of analysis before choosing binning pattern or partitioning pattern. The output format of each file could be different. One file's output format could be text output format, and another file's output format could be sequence file output format. And similarly, each file could have different output format. Also, the data type of key and the data type of value of each output file could be different. MapReduce framework provides support to specify different output format and different data types for keys and values for each output file. But in our example, the output format of all the files is text output format. But it is always possible to have different output format for each output file. Let's understand the code now. Here is the driver code. To create multiple output files from each map task, a separate built-in class is used. This class is called multiple outputs class. Using this API, we can specify the output format of each file. We can also specify the data type of the key and the data type of the value. But in our example, only text output format is enough. As a result, we are adding only text output format here. If the output format of all the files are different, then we must add all those output formats using this API. Here the second parameter is used to associate a name with the output format. Since I am using text output format, I gave the name as text bins. You can give whatever name you want. Number of reduce tasks must be set to 0, so that there is no reduce phase at all. Let's see the mapper class. Here we have to create an object of the multiple outputs class. We had specified the multiple outputs class in the driver code to define the output format of each output file. So using that context, an object is created here. We are creating the object in the setup function. So what is this setup function? Setup function is a function of the mapper class that is used to do initialization before the map function is called. This function is called only once for each map task, and it is called before the map function is called. Even the reducer class has a setup function, and it is called only once for each reduce task. Also, it is called before the reduce function is called. So both the functions are called for initialization. In the previous session, we saw the cleanup function. As cleanup function is used to do any cleanup at the end of the map task or reduce task, setup function is used to do initialization before the map function or reduce function is called. As usual, we are parsing the XML file here. We are extracting the tag field here. If the tag field contains Hadoop keyword, it is returned to the Hadoop tag file, and the file is created under the Hadoop directory. If the tag field contains pig keyword, it is returned to the pig tag file, and the file is created under pig directory. Similarly, we are searching for other keywords and writing the records to the corresponding file. We are also extracting the body field here. If the body field contains Hadoop keyword, then we are writing it to the Hadoop post file. As different files are created for each keyword, we don't need the output key. Hence output key is null writable. Since it is a map only job, there is no reduce class at all. Let's run this program on the Hadoop cluster and check the output. Now let's run the jar file on the Hadoop cluster. Let's check the input file first. Here is the input file. Its size is around 670 MB. So 6 input split will be created. As a result, 6 map tasks will be created. Let's check the map tasks and reduce tasks of this job. Six map tasks are created to process 6 input split. Since it's a map only job, reduce tasks are not created. Let's check the output file. For each keyword, a separate directory is created, and inside each directory, a separate file is created. These 6 map output files are from 6 map tasks. These files contain all the records that has Hadoop keyword in its tag field. And these files contain all the records that has HBase keyword in its tag field. In this way, data is grouped together using binning pattern. That was all about binning pattern. Thank you for listening to this session.